Hello, my name is Liang, and today the topic I want to introduce the biological Indian Ocean dipole event in 2019. Indian Ocean dipole IOD is a continuous difference in sea surface temperature between eastern and western equator Indian Ocean. And we can use DMI index as a measure of IOD. Australian scientists call DMI value above or below monthly average 0.4 degrees Celsius as positive IOD and negative IOD respectively. During the positive IOD, the weakening of westerning wind caused the upwelling in the eastern part of Indian Ocean, and this resulted in a colder SST and a shallow thermocline. At this time, the weather system is diverged, so there is not much rain. On the other hand, there is a warmer SST in west part. And because of the accumulation and sinking of seawater, there is a deeper thermocline. At this time, the weather system in this part will be Remi system. Basically, the impact of negative IOD is opposite of positive IOD event. The x-axis of this figure is concentration of nutrients, and y-axis is depth. Phytoplankton need nutrients to grow. So, in this case of upwelling, nutrients brought to sea surface to provide phytoplankton, and the chlorophyll A concentration becomes higher. Whether it is positive IOD or negative IOD event, it will have an impact on equatorial Indian Ocean, such as precipitation in East Africa, coral bleaching, and so on. We want to propose, identify, and quantify biological IOD, and further understand and solve the dynamic of nutrients, driving nutrients, as well as mechanism of abnormal biological activity. We use SNPP to observe and analyze chlorophyll A in the IOD region. SNPP is a satellite that can carry detector to monitor the Earth's environment and climate. SNPP can collect visible light and infrared radiation images from land, ocean, and atmosphere to observe fire, vegetation, and ocean color. Combined with the data from NOAA physical science laboratory, such as wide field vertical velocity of water, to understand the mechanism of abnormal biological activity. All data are monthly average from 2012 to 2019, including chlorophyll A, SST, DMI value, etc. This figure shows west and east IOD zone. Let's observe the change in SST first. In the next few figures, cold color means low value and warm color means high value, compared with the monthly average. SST in October 2019 was lower than -3 degrees Celsius in the coastal of Oriel, Sumatra. In other areas along the eastern shore, it has dropped between -1 to -3 degrees Celsius. However, in the western Indian Ocean, it is 1 to 2 degrees Celsius higher than the climate value. The DMI time series also shows that the IOD in the fall and winter is the strongest event in the past 20 years. Next, let's look at the chlorophyll A change in the East IOD area. Due to the proliferation of phytoplankton, the concentration of chlorophyll A in the eastern ILD area increased significantly. The coastal area of Sumatra, chlorophyll A reaches 3 to 4 milligrams per cubic meter in October 2019. And the typical value of the climate along the western coast of Sumatra in the same month was less than 1 milligram per cubic meter. The chlorophyll A ratio of climatology in October 2019 clearly shows that there was a large number of phytoplankton reproduction, and the ratio is reaching 4 to 5. In the east of Sumatra and Java, every chlorophyll A is similar to climatology. From figure D, we know that the abnormal growth of phytoplankton in the fall of 2019. And what is climatology chlorophyll A? It refers to the average value of chlorophyll A in the region for a long time. In this case, it is seasonal. We also observe chlorophyll A in the west ILD area. Contrary to the eastern ILD region in the coastal of offshore area, in October 2019 was lower than the same month's climatological data. From frequency, we can find that in some near-shore area, chlorophyll A decreased by more than 0.3 milligram per cubic meter. We can also see the abnormal biological activity in ILD event in 2019 from figure D time series. As an ocean atmosphere event, the generation of ILD is closely related to the atmosphere. From this data, we know that the strengthening of wind in the eastern part of Indian Ocean leads to an increased upwelling. And in figure A, the upwelling can be about 3 meters per day, and the average in figure B is less than 1 meter. Even if the data for October 2019 is compared with the October average, we still observe it is stronger than the climatology. On the contrary, in the southwest ILD area, 2019 September showed clearly downwarding than the average. It also occurred in October, but it was not so clearly compared to September. It means that in 2019, wind-driven and enhanced upwelling, it will bring highly nutritious seawater to the sea surface, causing phytoplankton to proliferate in the eastern part of ILD. However, in the western ILD region, the downwelling in September and October 2019 indicated that during the positive ILD, the thermocline become deeper, which may lead to a lack of substance needed for phytoplankton growth, resulting in a lower chlorophyll A concentration. It is worth to mention that during the negative ILD, the BMI value dropped to negative 0.5 degrees Celsius. Right-hand figure shows that the concentration of chlorophyll A in the eastern part of ILD was significantly lower than the climatology chlorophyll A, which shows that biological inhibition activity occurred in this area during a negative ILD event. Contrary to the positive ILD in 2019, as shown in and also right-hand figure, it can be seen that the chlorophyll A accumulation in the western ILD region slightly 2016. Compare the vertical velocity of seawater in 2016 and 2019. The dynamic obstacle to that in 2019 and appeared in 2016, such as the weakening of upwelling in the East ILD area. In this study, we use SMPP and physical data to know that during the positive ILD and negative ILD, positive ILD event in 2019, because the strong wind and along the east coast of the equatorial Eastern Indian Ocean, upwelling becomes stronger, and the sinking of seawater in the equatorial Western Indian Ocean. Due to concentration to surface water, the east and west change have caused clearly biological change in equatorial Indian Ocean. It shows that the concentration of chlorophyll A in the east ILD area increased from the primary value of 0.3 to 0.5 milligram per cubic meter in October of that year, compared with the primary value in the western ILD area. The chlorophyll A concentration in the west ILD area has dropped by more than 30%. Thank you for your listening.
I think he looked at audience more frequency than before, but I think you can say slowly because it's a little bit too fast for me.
Actually, I think you have to stop look at your notes. It's a quite problem, and you have nice PPT, but sometimes you will lose in your PPT because of the pointer and a little bit pronunciation problem.